out. Example 6, it's the same system we've been studying in examples 3, 4, and 5, but we want to put all those answers back together and find out what the complete solution will be. So I'm not going to redo all the work. I'm just going to quote the answers that we figured out in our previous examples. So in example 3, we solved the homogeneous system, which means we completely ignored all the inhomogeneous terms, all those e to the t terms, and we got x homogeneous was c1 times 1 times e to the 2t plus c2 times negative 1 times e to the 8t. So that was in example 3. You can go back and watch example 3 to see where that came from. In example 4, we focused on the e to the t terms on the right-hand side. So we looked at that, and we figured out a particular solution that produced those two terms. And that particular solution was 1, 2, e to the t. That was using undetermined coefficients. Very important here, there's no c's in here. There's no c1, c2, c3, anything like that. So there's no constants. There's no c's, because that's a particular solution. If you change the constants, you're going to be changing the answer and it won't work out. And then example 5, that was where we found a particular solution to account for the e to the 3t term, and that turned out to be, it was 3, 2, e to the 3t. And again, there's no constants involved there. You don't multiply that by an arbitrary constant. You just leave that. We very carefully found those coefficients 3 and 2, and you can't multiply them by anything without messing up your solution. And so what we want to do is just add all these solutions together, and we'll get the general solution to the problem. So all I'm going to do is just add up those 3 parts of the solution. I still have the C1 and C2 from the homogeneous part, e to the 2t plus C2 negative 1 e to the 8t. And now I'm going to add on each one of those x particulars. You can think of those as being the first particular solution and the second particular solution. 1, 2, e to the t. And for the second one, 3, 2, e to the, what was that, 3t. So e to the 3t. So we add all those together, and that is the complete solution to that inhomogeneous system. So let's recap everything I did in this example, which actually wasn't much work at all, because we did all the work in the previous examples. So if you haven't watched those previous examples, that's where I'm getting all these individual solutions for. We did all the work back there. In this example, we're just kind of assembling them together. So we first looked at the homogeneous solution, and then back in example 3, we found that the homogeneous solution had this form right here. And then in example 4, we looked at this part, the e to the t terms of the inhomogeneous solution, and we found a particular solution using undetermined coefficients that will produce that part of the inhomogeneous the inhomogeneous terms. And then finally in example 5, we looked at e to the 3t, and again using undetermined coefficients, we found a particular solution that would produce that part of the inhomogeneous terms. And remember, we don't multiply either one of those by C1 or C2. We do have a C1 and C2 in the homogeneous solution. Essentially, that's because the homogeneous solution, you're setting something equal to 0, and so if you multiply it by constants, it'll still work out to be equal to 0. But with the inhomogeneous solution, you've got some terms that are non-zero, and so you very carefully arrange your solutions, And if you multiplied them by something, that would be multiplying a non-zero number by something, and so it wouldn't come out to work after you did that. And so after we do all that, all of this was in the previous examples. You can go back and check those out to see where all these numbers came from. All we're doing in this example is just adding those together, just assembling the homogeneous solution, the first particular solution, and the second particular solution into one big solution to the inhomogeneous system. So that kind of wraps up our lecture on inhomogeneous systems using undetermined coefficients. We've got another method called variation of parameters, which is a totally different method for solving inhomogeneous systems. So I hope you'll stick around and watch that lecture. It's the very next lecture. You'll see we're going to learn about variation of parameters. But in the meantime, you've been watching the Differential Equations lecture series here on Educator.com. My name is Will Murray, and I really appreciate your watching. Thanks very much. Bye-bye.